Okay, quick little experiment recording the screen. As you can see, we've got Autodesk Robot Structure Analysis open, and you're greeted by this open screen. And what we're going to do is we're going to start a new project. We've got a couple of options with defaults for doing a frame 2D, frame 3D, a full building design. We're going to click on the More button and we get even more options. And we're going to go for the simplest one we can think of, which is a truss 2D design. Click on that button. Wait for it to load up. And we get greeted by this screen, which is the main screen for setting up an analysis. And we've got lots of menus, file menu, undo, view, geometry. This is the main screen that we need to use for setting up a problem. We need to eventually put loads on there. But the first thing we need to do is actually set up some geometry. Now, if we click on this button here that I've just done, and here I click on this library structure, this allows us to use some preformed structures that are very common. So instead of putting the geometry in with nodal coordinates one by one, what you get to do is just choose a typical truss. So I'm going to choose this one down here. I have no idea what the name of this truss is. I click on that and then I click OK. And now we get some options. Is what is the total length of the truss that I want? I'm going to go for, we got 1, 2, 3, 4, 5, 6 bays. So let's make it 12 meters so it'll divide nicely. And I'm going to go for a height of 3 meters. And number of fields is 6, we can change that. And we've got a couple of options that we really need to take care of. One is, do I want a continuous chord? And one is, do I want moments released? I'm not going to tell you what these do, because I think this is something I want you to tell me in your project report. But I'm going to say I don't want a continuous chord, but I do want the moments released. Okay. So then I've got some, what do I want as the section properties? If I click this button, I can choose all sorts of options, and some of them are from Australia, and we get another pull down. I can have an RHS section or an SHX section, UC, which is a universal column. So I've got lots of these choices. I don't really know what I'm choosing. I'm just going to choose an SHS, and then I get the section properties. So this goes 13 by, so I'm going to choose 15 by 15 by 1.8, and it gives me the option now, selection in the section preview. Let's have a look at it, what we've chosen. So we've got the full dimensions now, and all of these dimensions, let's check what the units of these dimensions are. So W, so we've got 15 is D, and presume that is millimeters. Let me just check, open that up a bit more. No, that doesn't help. Ah, that's better. And so this is a square hollow section, length unit is millimeter, so we've got 15 millimeters. That can't be right, that's tiny. Must be 15 centimeters, and 15 centimeters wide, and we've got 1.8 in the thickness. Okay, so we're going to choose this anyway. WB, that seems to have changed from what I had before. SHS, that looks better. So we've got a square hollow section 100, and we can change this to 75 by 75s. We can change it on the fly, and so we're happy with that. So close and click on OK. So that's the upper chord. The lower chord, again, we're going to choose the same thing. So Australian, we're going to go from the SHS section, and we're going to go 100 by 100 by 3, which was the same as we chose for the last time. Same with the diagonals. We're going to go again with exactly the same section, steel hollow section, and we've got 100 by 100 by 3. Okay, so we've chosen all the section properties that we want. Click on the next button, insertion point, scale cover. I have no idea what these mean at the moment, but I'm going to just take the defaults for now. So next button dimensions, sort of just gone back to the start, so I'm going to apply that. So now all of my bars in this truss know that they are that section. Now that's a little bit small on the screen, so click on the zoom menu. Zoom unit, zoom all, and that gets it nicely on the screen. So we've got the geometry of the truss now. Most of the stuff here, we've got the nose, the bars, panels, that was done automatically using that GUI. Materials, so we have the SHS by 2 and it knows that it's steel already. So material, steel, and we've got different grades of steel. Well, we're just going to choose steel, apply. Some of the members are different. Default one, materials changed for some bars created. Do you want to change it? Yes. And close. And if you want, you can click on a member. You should be able to click on a member and check what the properties are. So here we go, bar 1. So bar 1 we can check in here. If you need to open up the bars a little bit more, you can see this is bar 1, this red one down here. It's a simple bar, and we can check the length of it is 2 meters. We've got the numbers of the nodes 1 and 2, and we've got an SHS 100 by 100 by 3 section and a material of steel. Okay, so we can do that. Now, so we have all of geometry, all the material properties, all of the cross-sectional properties of the bars. The next thing we need to do is set up the support conditions. So, and we've got options here. We've already got fixed, pinned and Z direction fixed. And just check with the units we're using X and Z rather than X and Y's. So Y is pointing out of the screen. So we're thinking about X is the horizontal direction, Z is the vertical direction. You can actually change that somewhere in the menus. I'll leave that for something for you to play with. So I'm going to go with this bottom end. I'm going to have, so if I can click on nodes now, node 1, and I can see a little green dot highlighting that, and geometry, support, node 1 is pinned, apply, and you can see that a little icon has come on the screen showing you that that's got a fixity to it. And click at this end, or there. So node number 7 is the right hand end, and I'm going to just fix this in the Z direction only, and I'm going to apply that. Now in your program, that Z direction only might not be set. You might need to define a new support definition yourself. So if you see highlighted there, click on this button, you can define your own support conditions. Okay, so I'm going to close that. I have it fixed. Disappears off the screen. It's one of the awkward things with this program, that things seem to disappear off the screen. Don't know how to get that back. You'll work out how to use it better than I will. Okay, next thing, or last thing we really need to do, is define the load. So, and we get this type of load cases, and this is really useful for when you're using this in practice, when you want to use dead load and live load and different combinations of loading. For me, I'm just going to go with a live load. Don't know what this sub-nature business is really done on the design standards, but I'm just going to leave it as live load 1. Add. Close that. And then loads, then I can have load definition. And I've got some options now. Don't want it on the node, on the bar itself. So I can have UDLs, but we've got trusses, so we can't apply UDLs to the bars. And we're allowed to have south weight or not south weight. Something that's worth considering later on, whether that's included in your analysis or not. But I'm just going to add a nodal force. Again, Z is the vertical direction, and this is just an example, so I'm going to put minus 10 kilonewtons, and so add that, and I'm going to apply it to whatever that node is there, which is, I'm going to close that bar. -10, add. Nodal force applied to 1, 2, 3. So let's find out where the node is. Node 7, 8, 9, 10. So 10 is this top node. You can faintly see a little green dot there, and apply. And we've got this load indicated on there. So I can close that. I now have the load. I'm going to have 1 point load only. And file, you can save the structure if you want. I'm just going to go analysis, analysis types. You get lots of options on the analysis. Structure model, load to mass conversion, da 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 da. I'm going to ignore all of these. But here it's already chosen for me. I want to do a linear static analysis. Okay, and then I can click the calculations button there, or straight away underneath the analysis tab, click calculations, and this will run the calculations. Runs really quick, certainly much quicker than doing these by yourself. I have no errors, that's good. And number of one, parameters of the material used in the object are different from parameters defined in preferences. Okay, I'm going to ignore that for now, but could be something important later. So the program has run. Now what you'd want to do as a designer is actually look at some of your results. And so again, go across the top menu, I can click on results, and we get a couple of options: diagrams for bars, maps on bars, reactions, displacements, forces, stresses. I'm going to click on this diagrams for bars, and again you get another set of menus. And what I'm going to do is click on this FX force and apply, and we just get some diagrams that are not particularly useful. So I'm going to turn that off. One thing that is nice to see is the deformation, just a sanity check that it's deformed in the right direction. So you can see the black line was the original structure, and this orange line now is the deformed structure. We had a roller on the right hand side, so the structure also deforms slightly to the right hand side as well. Okay, and you can play about with the scale that you want for there. Other things you might want to look at is the maximum stress. There's only one stress in a bar. Let's apply that. And again, this size from here gives an indication of what the stress in the bar is. This isn't particularly useful in this case. So stresses, so I'm going to turn that off. We're going to see if we can find a better way of looking at that later. So reactions, FX and FZ in the global system, we can choose to have that in a local system, so along the axes of a bar. We're not going to do that, and we're going to apply that, see what we get. And now we get the two reaction forces. All we get is pictures here. Let's see, and somewhere we should be able to get the results in some kind of tabular output as well. So diagrams for buildings, detailed analysis, advanced, interaction forces, diagrams. Let's click on the detailed, or let's click on forces. What's it give us? So we can get all of the forces in the structure, and they're done by nodes. Not quite so easy to read, having them actually on the bar. So let's see if we can, in the results, maps on bars, see if this is useful. So X components, scale, so somewhere between yellow and red, hopefully. Let's click on the structure deformation so we see the deformation as well, hopefully. Click on the button, and now we can see the red bars which are in compression, and the blue bars which are in tension, and we've got some green bars which are somewhere in between. Okay, so that's just a quick demonstration of getting started with robot structural analyses.